Hey guys, so if you've been checking out my Instagram page, you know that I promised y'all a more elegant solution to this arithmetic sequence problem. So this problem requires some formulas to memorize, which is one of the reasons I didn't include it at first. But let's just jot those down first and have them for reference for later. So the first formula to know is that a of n, the nth term, is equal to the a of 1, the first term in the sequence, plus n minus 1, again the nth term, times d, however much each term is getting increased by. The second term we want to know is, or second formula I should say, is sum of n, so the sum of the numbers from 1 to n is equal to n over 2 times a of 1, the first term, plus a of n, the nth term. Alright, so we'll have these two formulas in our back pocket and start trying to solve the problem from there. So let's start by solving for d, the difference, or however much each term is getting incremented by. Well, we have our 6th term here and our 10th term here, and we know that the difference between them is 13 minus 8, and we also know that there are 4 terms between them, right? Because 10 minus 6 is equal to 4. So we'll divide 13 minus 8 by 4, which is equal to 5 over 4, which is equal to 1.25. So each term is being increased by an increment of 1.25. You can double check that here. I wouldn't, again, do this on the SAT, but just for YouTube's sake, I'll do it here. We got 9.25, which is 8 plus 1.25. 9.25 plus 1.25 is 10.5. 10.5 plus 1.25 is 11.75, and 11.7 plus 5 plus 1.25 is 13. So we know that we have found d, our difference of 1.25. Knowing this, let's try to solve our first term over here, a of 1. Well, we can actually manipulate this formula over here to do that without having to solve for each term over here. How? Well, we know a of 6 is 8, right? So a of 6, which is equal to 8, is equal to a of 1 plus n, which is 6, minus 1 times 1.25. So this is equal to a of 1 plus 6 minus 1 is 5 times 1.25. And if you have a calculator, I would probably take that out right now to use this. This is equal to a of 1 plus 5 times 1.25, which is equal to 6.25. Alright, so because we have a of 1 plus 6.25 is equal to 8, we know that a of 1 is equal to 1.75. So now we have our first term, a of 1, and using this formula, the question asks for the sum of the first 4 terms over here. We just need to find the 4th term so that we can plug it into this equation over here. We don't need to find each individual term, we just need to find the first and last term and then multiply it by n over 2. This is the beauty of these formulas. It allows us to not have to brute force our way through these problems and just kind of find a more elegant way where we only calculate the necessary parts of the answer that we're looking for. So first 4 terms, we want to find the last term, so the 4th term. So we know that a of 4 is equal to a of 1 plus n minus 1 times d, which that is equal to 1.75 plus 3 times 1.25. Again, I would take out my calculator here for this. So 1.75 plus 3 times 1.25, that is equal to 5.5. Cool. So lastly, now we'll have to find the sum, right? The sum of 4 numbers is equal to 4 over 2 times a of 1, which is 1.75, plus a of n, which is 5.5. This is equal to 2 times, take out my calculator again, 7.25. So this is equal to 14.5. So our answer should be 14.5, all right? But just for fun, just to double check, let's actually go through and find each term of the sequence. This would be a good thing to do, let's say if you had like, I don't know, 10 minutes left in the exam and you just wanted to really double check every single answer. I wouldn't do this the first time or first round of solving the SAT, but again, if you have extra time, it'll be nice reassurance. So a of 1 we already found out was 1.75. So, and the difference is d, 1.25. So that means, let's see, a of 2 is 1.75 plus 1.25, so that would be 3. A of the third term is 3 plus 1.25, which is 4.25. And the fourth term is 4.25 plus 1.25, which is 5.5. So if we were to add these numbers together, we would get 1.75 plus 3 plus 4.25 plus 5.5. And in the end, that is again 14.5. So this is the beauty of math. We've proven, or not we, smarter people than I have proven that these formulas hold true for any arithmetic sequence. So using these key ingredients, we can just solve for what seems like a really brute force way of solving a problem in a really neat and elegant way. Now, I don't know if this is the better approach for you personally in a test, or if you want to brute force it. That really just depends on your experience, what you're more comfortable with, and how much time you have left. But this is just another elegant method of solving one of SAT's more challenging questions. If you think this video was helpful, follow, like, comment, share to your friends, and just don't be a gatekeeper.